Welcome to Velocity Space, and here's a story on how I built my TVC model rocket.
Hey guys, welcome back. So I know I haven't posted in a while. That's mainly because school started and now I got to focus on that. And I'm studying for the ACT now, so I'll have even less time. But as many of you know, a snowstorm recently hit down here in the south, and so I have about a week of free time before school opens up again. And so let's catch up. So recently, I haven't really done a whole bunch of rocket stuff. I've tweaked the code a little bit, and I've launched it. So y'all get to see that in this video. However, the footage is a bit bad, so please don't, be mean about it in the comments. And then after this project, I think I'm going to start something like a product-based business. I think I'm going to create kits of these rockets or something similar to these rockets and sell them. Maybe Shopify, Amazon, something like that. But that means y'all are going to have to be my advertising, because I'm not paying for no advertising, at first, because I don't even know if it's going to work. But let's get into the video. Alright, before we get into this video, let me show y'all the video clip of me launching this rocket. And I apologize for it being vertical because my mom did not know how to shoot it in horizontal, and so let's just deal with it.
Oh, perfect. Perfect.
Yeah, so as y'all can see, everybody was pretty excited in the video. But now, let's get back to the actual video of me explaining how I built all of this. So, let's get into it. I know I already made these videos in the past, but I think I'm just gonna, make them again so new people coming in, they don't have to watch the old videos to catch up. They can just watch this one video and know everything about this project. So let's start from the core. You need your TVC mount. Or actually, let me say what I'm trying to do. So this is a thrust vector control rocket. It uses thrust vectoring like this. It gimbals the rocket motor, and it will steer the rocket in a direction that that you want. But in this case, I'm just stabilizing it. And to do that, you need something called a gimbal. So this gimbal, it just, it can move in your y-axis. Oh gosh. Alright, so this gimbal, it can move in your holy. And so this gimbal, it can move in your y-axis and your x-axis, right? And then you got your servos that are the actual things doing the moving. And now you got these cables. These cables connect to your flight computer right here. So, oh gosh. So this is the flight computer. Sorry, I don't have it screwed in, but basically what it does is it has an Arduino. Okay, we don't need any of these. So it has an Arduino SD card mount, or an SD card reader, an IMU, a MOSFET, these pyrotechnic outputs. It has a buzzer and an RGB LED over here. Oh, and it has a BMP 280 that senses barometric pressure in the atmosphere, so it knows how high it went. However, that wasn't very good. It also has the output pins for your servos and a capacitor to smooth out the voltage coming out. Now, after this is connected, it will go into an airframe, which an airframe is right here. So, this is an airframe. I named it Velocity 1. That's this rocket. And so this, it would be mounted on these mounting rings right here. So one would be, let's see, one would be on top, like this. It'll just clip in, so it's got like these grooves, and it just clips into this. And then the bottom one, it's also got the grooves, and I labeled them oh shoot, actually this is the bottom one. So the bottom one I labeled it X and Y, so I know which side goes to the x-axis and which side goes to the y-axis servos. You do not want to get them mixed up. If you get them mixed up, your rocket will not fly. It just like will not work. And this is your top mounting ring right here. It goes on like this. And then I have a back cover right here. This back cover, it just mounts onto the back of here, and it's got a little cutout here for your battery output, or your battery input, I mean. And then this whole thing, it'll just slide into your airframe, okay? Okay, so now that I explained everything, let me demonstrate to you how it works. So I got these, the mounting rings screwed in and the back cover screwed in. And now I will plug this into a 9-volt battery. So I plug that in. It'll go through its bootloading cycle. So it'll flash the green light and beep. So right now it is going through all of its cycles, checking to see if the flight computer is level, checking to see if there's an SD card in. Okay, now that I went through all of the cycles, it is now in a pad idle mode, meaning it is constantly looking for a launch. Now, something you look for when you're looking for launch is your G-forces. Because right now, you know, as humans, we're experiencing 1 G of acceleration. Now, when a rocket launches, it'll experience maybe 2 Gs, 3 Gs, 4 Gs, 5 Gs, because it is a very fast acceleration. And so, if I go here, you can see it detected launch. Now, if I move it, you can see it is now moving the gimbal, because it thinks it's in launch. Now, you can see the gimbal is not moving very much, because you don't need to move it very much. You just need to move it slightly and it'll correct a whole lot. Now it is constantly looking for a burnout. So just like detecting a launch, a burnout, it's looking at your acceleration. So if you're going very fast and then you suddenly fall, see now it stopped. Right? It stopped and then it sent 9 volts, or it told this MOSFET to open to 9 volts, and then it will send 9 volts to these power charges. Okay, now this is cool. Now we gotta look at how it actually comes back to the ground. So I don't know if you can see very well, but in there's a plate. There's a white plate, and then if I open this up, there will be parachutes in here. And let me show you. So this is a type of power charge that I use. It just goes into these are called Wago connectors. These lever connectors, you just flip them up and then you close them to lock the wire in. But basically these 2 wires go into here, and when it sends 9 volts through, this will shoot out. So in here is a pyrotechnic charge that will actually explode, right? And there's an igniter in here, and when it ignites the charge, it explodes, and there's a whole bunch of high pressure gas in this chamber, and then it'll blow this out, and then, you know, thus coming down to the ground. Now, all this is cool, but it will never work without software. Software is the code that's like, software is code that is on this microcontroller, this Arduino, that runs everything. It runs your setup, it runs your pad idle mode, it runs your in-flight, it runs your burnout detection, and runs everything. So, next, let's look at the code. Okay, so now that we're looking at the code, let me go up. So, here we're at line 1. So, let me just start from line 1, and I'll talk down the project. So, as you can see, we're in the Arduino IDE. Our IDE stands for Integrated Development Environment, I think. Integrated Development Environment. Developer Environment. Anyways, it's basically an app that takes your human readable code, In this case, it's C++ or Arduino C++, and it turns it into zeros and ones that the Arduino can read. The Arduino, which is an ATmega 328P, that's the microchip that's actually reading the zeros and ones. Alright, so now, the first 6 lines of code is just, notes for me so that I know what I'm looking at. So, like, things I got, G&D stands for ground, VCC 5 volts, MISO, MOSI, SCK, CS. That's for, I forgot what it's called, but it's a type of communication protocol used here. So, I haven't worked in this in a while, so I kind of forgot some of it, but I'll try to explain to the best of my ability. Here you include your libraries. Here you declare your servos, and then here you create your file log for your SD card. Okay. Here you declare your IMU. In this case, the IMU I'm using is the MPU 6050. Okay, so I got to declare that so Arduino IDE knows what I'm using. And then I got to do my Adafruit BMP 280, which is your altitude sensor, and it's made by Adafruit. That's why it's got Adafruit here. Here you set your variables, your integer variables. So say I got buzzer on 7, red, 6, green, 2, and then my pyro, servo, base. This is for your barometric pressure sensor. Okay. That is, a base pressure, so it knows what pressure is at 0. So basically, these are all your variables. And let's go. So here's your setup. I'm not going to go through all of it, or I'm just go through really quick so I don't bore you all. But basically, these are your functions for setups. And here's a function to log data to. And this is your actual void setup. So you start your serial, you start your servos, and then you declare your pin modes, and then you start. So, you start initiation, and then you go to sd.begin, which begins your SD card logging, or it creates a file in your SD card. Okay. And then it actually sets the format in the SD card, and then it begins your IMU to make sure everything is good in your IMU. No wires cut or anything shorted out. And then it starts your BMP, which is your barometric pressure. And then the IMU and BMP both use something called I2C protocol. So this is your I2C address. And the other one that used MISO and MOSI, that was your SD card reader. That is called, let me think. I think that's called serial. No, that's not serial. I don't know. Search it up. I'll put it on there. Okay. And then now you go into your control algorithm. So this is your PID algorithm and your logic for detecting launch. So here, if it's greater than 1.2 Gs, then that means launch is detected. And then it starts running your control algorithm. Here, down here, if it is less than 0.4 Gs and it knows it was just in launch before, then it will send 9 volts to your pyro channel and shoot out your parachutes. And down here, if nothing is detected, then that means it has to be pad idle. Down here, if nothing is detected, that means it has to be pad idle, and so it just centers the gimbal. And that's a basically quick, brief explanation of the code that is on the flight computer that controls the rocket. Okay, so now that we talked about the code, now we talk about the launch pad. So the launch pad is a thing that actually, ignites the motor inside the rocket and launches it in the sky. So we have a launch clamp, this thing right here. This will go on the bottom of your airframe. So here's your airframe, right? And this will just clamp to the bottom of your airframe like this, and it screws in to your TVC mount so it holds, okay? And now this goes onto here like this, and you got these little arms. And it's also got a groove in here, and the arm has a little channel that dips down and locks into the groove. So like this, it locks in, and then you have another arm here that holds it up. And you got 4 servos connected to, this is your launch computer. So in your launch computer, it's a lot more simple than your flight computer. You have an ESP32, and you have 2 MOSFETs and a relay. So right now I'm only using the 2 MOSFETs. The relay is only there because I didn't think I needed it, because I thought I needed it, but turns out I don't. And you also have a voltage regulator that regulates a 3-cell LiPo down to about 5 volts for your ESP32. Now, how this mechanism works is if there's a servo here and it moves, it'll just knock this arm out of the way and it springs down like that. And now this will go. Also, the code for the flight computer is also very simple, although this does have Bluetooth, so it is more complicated in that sense, I guess you could say it. So we'll take a look at that next. Okay, so as you can see, we are in the Arduino IDE once again. However, this time we are programming in ESP32, but it's the same language. It's just Arduino is also compatible with many other brands of microcontrollers. So this is your ground software. Just like the flight software, you also need to declare variables, libraries. So this library is the Bluetooth library, and then here's the ESP32 library, so that Arduino knows that we are programming in ESP32, not an Arduino. Here you need to start something called a Bluetooth address. So I call this Bluetooth serial BT. So that is what I assigned the address as on the ESP32, so my computer knows what to connect to. I declare 4 servos, I declare my power channels, and then I declare these pins, which are the pins for my servos. Okay? And now we go down to here. So if I type 1, if I send 1, then it knows to fire power channel 1. If I send 2, then it knows to fire power channel 2. If I send 0, that means don't fire anything. Just stop. So this is really simple. It has no complex PID control algorithm. None of that. It's just Bluetooth and then serial, and then if sends a 1, a go, or 2, simple. Alright, now, none of this would be possible without something called CAD. CAD is called Computer-Aided Design, and it's a type of software that engineers use when they want to design something on the computer so the computer can actually help them design it. For example, the TVC mount I made, it is 3D printed. A 3D printer doesn't know what to print if you don't tell it what to print. So, you need to design a part in the computer, create it as an STL file, and then send it through something called a slicer, and then you got to print it, and then, all that. That can be in a video of in its entirety. But let's just talk about the CAD for this project. Okay, so now we are in another software called CATIA. CATIA is a, professional CAD software. You do have to pay though, so it is slightly expensive, but it is a really good CAD modeling software. Here, okay, so that actually looks really ugly, but basically what all you're seeing, all these white things, that's the planes. It's complex CAD terms, but anyways, here you can see the launch pad and the launch pad, arms, like here, and the servos. I also modeled them. And I forgot to mention this, but the launch pad had a flame trench. The flame trench is used to help direct the hot gases coming from your rocket motor, and it direct them away from the wood, that's made of, so you don't want the wood to burn. Next is this, which was your clamp platform. Okay. After that, you go to your TVC mount, which is right here. I mean, it looks the exact same because it is the part that actually, that's here. It looks the exact same. Next, you go to your flight computer. So here I just tested it to see if everything was, gonna fit, and it's not exact, it doesn't have all the wires and stuff, but it'll work. Here is your pyrotechnic platform. This was the white plate that you saw that was inside of here. Yeah, that's the white plate that's in there, okay? And let's go back up, and here's your nose cone. The nose cone's pretty self-explanatory. It's the nose cone. And yeah, basically, engineers do something like this every single time they want to design a product, so they can have a visual idea of what this product is going to look like. Now, I feel like I've explained everything about this project. Now, let me explain everything about the project after this. Okay, so let's talk about the project after this. The project after this was inspired by Joe Barnard at BPS Space. He built something called this VTOL thing that had a propeller in the middle, and it had fins, it had thrust vanes on the side that would control or, help stabilize this vehicle. I kind of have an idea in my head, but I haven't actually put it into the computer and put it in as a 3D design. And so, comment down below if you think that's a good idea. The project is called Sprint or Sprite. And just search up bps.space, Sprint, or Sprite. I'll put it up on the video. But basically, after I get that done, I'm wanting to create a STEM kit. Okay, I'm going to actually start a business doing this. So, comment down below if you think that's a good idea. And if you enjoyed this video, make sure to subscribe. If you liked it, then, give me a thumbs up. And share this with your friends who like rockets. Thank you, and I'll see you next time.